appreciated. And thanks to you and to the transfer team for the invitation to talk about new vehicle fuel economy and vehicle emission standards. So I think that should I start? Let's see. Can you see my presentation now?
Yeah, it works well.
Okay, perfect, excellent. Should I give a wave hello to the team?
Yeah, you may have a short introduction or explain what ICCT's work is focusing on or so. So that's fine.
Okay. Let me see. Okay. So let's start with a brief introduction to the ICCT, and then we're going to move basically devote about the same amount of time to vehicle emission standards and to vehicle fuel economy and CO2 standards. The idea for me is to give you a general overview of what these policy tools are and what are the scopes, what is the benefits, the costs, and the challenges for implementation. So ICCT is basically an international independent non-profit research organization, and we devote our efforts to support environmental authorities in countries around the world with technical and scientific research information for them to take the proper policy decisions. We work mostly on the road transport, passenger cars, trucks, and buses, and also on aviation and marine. Our funding sources are basically private foundations and specific research projects. We have offices in the US, in Europe, in Berlin, and we are opening one in Beijing, in China. So before we start, I think that we should take a brief look into vehicle testing. This is a key element because this is basically a source of information on vehicle emission standards and vehicle fuel economy standards. So I hope you have right now the slide. So slide number 5. This is basically a typical look of a vehicle chassis laboratory testing setup. So compliance with new vehicle emission standards is determined through laboratory testing conditions via very strict testing protocols. The vehicle is placed on a chassis dynamometer where the wheels are placed in contact with the spinning roller, which is number 1. The roller itself offers a resistance to the wheels, preventing them from rotating freely. That is equivalent to the road load that the vehicle experiences due to inertia, which is the weight of the vehicle, the aerodynamic drag related to the shape of the vehicle, and the rolling resistance, which is provided by the wheels, the tires in contact with the road. So the driver will follow a specific speed trace, which he's going to be watching on that blue little screen that is shown on numeral number 2. And this test lasts for about 20 minutes. During this period of time, exhaust gas emissions are collected and analyzed on the analyzers, which is number 3. And based on that information, the vehicle will receive basically its pollutants. The regulated emissions of gas pollutants are measured, and fuel economy and CO2 emission values are determined. And this is very important because those two are different. They are regulated differently. Pollutants and fuel economy or CO2 standards are two different type of regulations that are based on the same type of emission testing under the European program. So let's talk about the first topic, vehicle emission standards, regulated pollutant. So these apply to new vehicles and have to be met on a per vehicle basis. And it's very important to note that vehicle emission standards are different from roadworthiness emission testing, which is something that people has to take in-use vehicles to local laboratories and do a few minutes test. That's a completely different story. So why we care about this? Because vehicles are a significant source of air pollution in many cities around the world. And vehicle emission standards are the best policy that will make sure that the cleanest technologies are applied in the new vehicles that are entering the market. So vehicles, emission standards for new vehicles are what we call technology enforcing standards. It is important because the vehicle population is growing very quickly. This is specifically, this is shown strongly by the behavior of the Chinese and the Indian passenger vehicle market, which has annual growth rates during the last 10 years around 8% to 13%. Also, developing countries in Latin America and Asia Pacific region are also growing between 4% and 7% per year. And it is estimated that the growth, although it's not going to be as high, is going to still be very large for the next 40 years. So this might become unsustainable for many cities. And if we want to tackle the air quality issues, vehicle emission standards are one of the best tools to deal with this situation. So if we want to achieve clean air, then we need to reduce the contribution from the transport sector. So policymakers have basically two main options to tackle this: reduce vehicle activity, or they can reduce vehicle emissions. Vehicle activity covers, as an example, low emission zones. And if the idea of adopting vehicle emissions is to adopt the most stringent vehicle emission standards limits that are possible for that specific market. This is very important. There are two keywords here: the limits themselves and the possibility. What is possible to request or to implement on a specific market. So let's take a look at the evolution of vehicle emission standards. This slide shows the evolution for nitrogen oxides, NOx, and for particulate matter, PM, for diesel vehicles in Europe and the US. Today, Europe is at Euro 6 levels. This means that PM emissions are about 90% lower compared to Euro 2 emission limits, which were implemented 20 years ago. This is important because this Euro 2 emission standard, this 20-year-old standard, is the most common standard across most of Africa, the Middle East, Southeast Asia, and some countries in Latin America. A shift to Euro 6 standards will have a dramatic positive impact in air quality in those cities in the next years. Now, you may wonder, I have seen many new Honda Civics and Ford Fiestas that look exactly the same as those new vehicles. I have seen those vehicles in Philippines or Bangladesh, and they look exactly the same as those vehicles in Europe. Aren't they the same? So the answer is no, they are not the same. Emission standards are different, and emission standards define the emission control technology that is placed in those vehicles. This is why this is called vehicle emission standards are called technology enforcing standards. Note in this slide that as the emission limits are reduced, as the emission limits are tightened for PM and for NOx, the list of technologies required to meet the standards increases. And the most, picking one of the technologies, probably the most significant is the adoption of diesel particulate filters for particulate matter control. this was implemented or was required by the Euro 5 standards. And there are also other technologies like improving the fuel injection pressure, which almost tripled from the very old Euro 2 technologies to the newer Euro 6 technologies. So the main point of this slide is that there is a huge difference in technology between a Euro 2 vehicle that is produced today in a developing market, a new Euro 2 vehicle that is produced today, and a new Euro 6 vehicle that is produced today in Europe. And the importance of these new vehicle emission standards is to make sure that these new technologies, clean technologies, are adopted in those new vehicles that are being sold. Now, then why don't we just advise all the governments to move to Euro 6? That would be the logic solution. The answer is that we need to talk about the link between vehicle emission standards and fuel quality. This slide shows diesel emission standards progression from uncontrolled to Euro 6 and the required maximum levels of sulfur content allowed. Removing sulfur from diesel fuel is important because A, it enhances the efficiency of most catalytic systems for hydrocarbon, CO, and NOx control, and B, it enables the adoption of diesel particulate filters, DPFs. So in summary, basically the main barrier to adopt, the main challenge to adopt Euro 5 and 6 in most countries around the world is the availability of fuel quality of ultra-low sulfur diesel and having a diesel in the market that has a content below 15 or 20 ppm. Now, reducing the sulfur, and I think it's very important to stress this, reducing sulfur in diesel to less than 15 ppm allows for DPF's adoption. And the DPF, the diesel particulate filter, is the most effective technology to reduce particulate matter, especially from urban buses and trucks. This is especially important for reduction of respiratory illnesses. This is a slide that shows the improvement on the content of particulate matter from the exhaust of a vehicle with the adoption of PM control technologies, from non-control to passing through the adoption of diesel oxidation catalyst, then to a partial filter, and lastly to the DPF, the diesel particulate filter, which allows for PM reductions between 85 and 90%. So 85 to 90% of total PM emitted by the engine is captured by these filters when they are installed in those vehicles. So this illustrates the importance of the link between diesel fuel quality and the adoption of advanced emission control technologies in diesel vehicles, specifically for particulate matter control. Now, the next question is, then why do we just adopt ultra-low sulfur diesel in all the markets? Well, there is a cost associated with reducing the sulfur level, with desulfurization of fuel for gasoline and also for diesel. But we have been studying, the SUTP has been studying this issue, and we have observed that the increase in fuel costs due to investments in low sulfur fuels, all the technology required to remove the sulfur from the diesel, this cost result in about 0.5 cents to 2.8 cents per liter. That will be the increase to the consumer at the fuel pump. This small amount, let's say even from 0.5 to 3 cents, even 3 cents per liter, is a small amount compared to the annual variation of fuel price in any country due to oil price volatility. In other words, the sulfurization costs are literally noise compared to the variation of the fuel price signal in any market. Now, from the vehicle side, adopting cleaner emission standards imply that there is a cost in technology due to new hardware, new equipment that has to be implemented in the vehicle, and research and development costs. So this slide shows the cost of upgrading from Euro 3 to Euro 6. That implies about $40 for a gasoline vehicle. And this same upgrade or change in emission standards will imply an additional cost to the manufacturer of $1,100, $1,100 for a diesel vehicle, which means that for gasoline vehicles, the economic barrier is very small. For diesel vehicles, is more challenging because all the technology that has to be implemented to control these PM, particulate matter, and NOx. But even though, well, let's say that the experience, what we have observed during the implementation of the most advanced emission control standards in the US, the heavy-duty 2010 rule, and the European Euro 6 standard, all these implementation projects, we have observed and analyzed the cost-benefit analysis performed, and the experience shows that adopting new vehicle emission standards for light and heavy vehicles results in significant benefits, and that the benefits always surpass, they are higher than the cost of implementation of the rule. The improvements in air quality bring through a combination of ultra-low sulfur diesel and advanced emission control technologies can lower fatal rates of heart and lung diseases and other respiratory diseases. It also reduces hospitalization and sick days and all the associated costs that are derived from the health care and loss of productivity from people who are sick and cannot go to work. So while compliance costs are estimated within a range of almost $2 to $14 billion, the benefits usually vary between $2 billion to 100 billion in annual savings. So benefits are generally higher for heavy-duty vehicles due to the massive benefits obtained on PM emission reductions. And the benefit to cost ratio typically range, just as an example, for a light-duty vehicle program between 5 to 1, that's the ratio, to 16 to 1 for a heavy-duty program implementation. So in general, the message is vehicle emission standards provide more benefits to the society than they cost to the society. So finishing up on this presentation, this first part of the presentation, we can say that new vehicle emission standards are the most powerful and cost-effective tool to reduce road transport and many other emission impacts on air quality. Adoption of stringent standards demand introduction of advanced emission control technologies, like we saw the example for diesel vehicles. And the technologies are already in place in developed markets, and the main barrier for global adoption is basically fuel quality, especially sulfur content. The costs of obtaining ultra-low sulfur diesel, we have studied the case, and it's usually below 2 to 3 cents per liter for some of the selected markets that we studied. The cost of clean technologies that are required in those vehicles, let's say the upgrade from Euro 3 to Euro 6 will be $40 for gasoline vehicle and about $1,100 for diesel ones. And the benefit to cost ratio is usually very good and higher for programs that target diesel vehicles. So let's move to the next topic of our conversation, our webinar, which is new vehicle fuel economy standards. I will say that it's very important to differentiate both. During actually my personal interaction with environmental regulators, these two type of programs tend to be confused, and it's very important as you are approaching this topic to have a clear differentiation between vehicle emission standards that control air pollution emissions from vehicles and fuel economy and greenhouse gas CO2 standards that regulate the fuel consumed or the CO2 emitted. Those are two different sets of programs, and they're regulated independently. So why do we care about this? Well, vehicles, the global transport sector actually responsible for almost 1/4 of all CO2 emitted due to human activity. About 9 gigatons out of 38 gigatons are estimated come from the transport sector, and about 3/4 of that comes from the road transport sector specifically. So about 18% of all anthropogenic CO2 comes from the road. This is why we're talking about 7 gigatons annually for the global fleet of vehicles. And the growing fleet that we saw before will push absolute emission values even higher unless and it will probably double by 2030 unless we set some strong reduction targets for CO2 emissions. The current standards that have been adopted by some governments around the world, including the US, Europe, China, India, they will provide some relief, but the global potential is almost double of what has been agreed already for the transport sector. So let's talk about what to do, how to fix this. So we can reduce carbon emissions from a growing fleet. Basically, there are three main sources. We can tackle the vehicle, specifically vehicle fuel consumption. We can approach the carbon content of fuel, or we can deal with the vehicle activity, how many kilometers the vehicles are driven per year. The idea with the solution is to adopt policies that will help reduce each of these contributing factors. In this presentation, we're going to focus on new vehicle fuel economy standards to the left. Carbon content reduction can be approached with low carbon or renewable fuel policies, and vehicle activity can be improved with traffic management programs and including public transportation. The most important element is that new vehicle fuel economy standards approach directly new vehicles, the new vehicles that are coming into the market. The metric.
Okay. Now you're back, and I'm back.
Oh, you lost me for.
Yeah, I lost you for about half a minute. So
half a minute. Oh my goodness. Which slide were we? You lost me.
Yes. So here at you showed the new vehicles, so the lowest blue bar, and then I lost you. I don't know how it was for the others. It could be that it was also a problem just on my side.
Okay. Then I will continue from this point.
Yeah, that would be great.
Yes. So I think that one of the main characteristics of new vehicle fuel economy standards is that they tackle new vehicles, and which trickle down the impact is larger in the future as new vehicles become larger and larger in the market, and the carbon content and vehicle activity they cover the whole fleet, the new and the well, specifically the vehicles that are already in use. So let's talk about the key points of vehicle CO2 emission standards and fuel economy standards. And I think let's start with the regulated metric, which is that there are basic three metrics that are used commonly among different programs. Fuel economy, which describes how many kilometers have been used per liter of fuel. Fuel consumption, which is the inverse, how much fuel has been burned per kilometer driven. and CO2 emission, which is the standard that the European Union has, which is how much CO2 is produced per kilometer driven due to fuel use. So basically, all of these three metrics speak about exactly the same. It's about fuel consumed and CO2 emitted. And countries have different approaches to adopt this metric. The US, Europe, and Canada has CO2 standards. Japan, Mexico, and India has fuel economy, and China is the only one that uses fuel consumption for fuel economy standards. Do not confuse with fuel economy label. We're going to talk about fuel economy label information a little bit later down the road. So they are basically the same type of information. Now let's talk about the form of the target curve and the underlying attribute. The European Union, and I use this example because it's the closest to you, uses a continuous target line for fuel economy, for CO2 emissions, and this target line is based on the vehicle weight. So it's very important to notice that unlike air pollution standards that are unique values for all vehicles, those are per vehicle standards, these CO2 emissions programs, standard programs, have targets that are proportional to vehicle weight or footprint, and they are not assessed on a per vehicle basis, but are assessed on a manufacturer average basis. So the regulated entity is not the vehicle specifically, the target is not the vehicle, but the manufacturer itself. Let's say, as an example, the heavier vehicles, BMWs, have less stringent standards than lighter vehicles such as Fiat's. The objective of this type of target design and the slope is to make sure that the average fleet value is conserved, and it doesn't disturb too much the market. So BMW doesn't have to start producing smaller vehicles to be able to meet their requirement. Remember that the important component is that the fleet itself drops in CO2 emissions. So it gives some flexibility to manufacturers, but it also fulfills the intended idea, which is reduce the average of the fleet CO2 emission values. A brief example, this is another approach. This is the United States, the EPA approach to fuel economy, which is the same as CO2 emissions. And instead of being based on weight, it's based on footprint. So this is just wanted to show you a different approach to setting the standards. Now, the next element that is important to talk about is the target itself, the value. Because different markets have different, let's say, characteristics. The US is well known for having the largest vehicles with larger power, engine displacement. They are heavier vehicles, while the market in India is dominated by subcompact type of vehicles, very light and very fuel efficient. So it is very important that the targets, when designing the fuel economy regulation or the CO2 regulation, the market itself is characterized first before moving to set a specific target. And because each market is different, each country has its own starting point, let's say the baseline, and it has different targets towards the future. And this list of about 11 countries show what has been already adopted around the world. So these are the few countries that have already adopted fuel economy or CO2 standards. And the US have a long history of fuel economy standards from the 70s. Europe started in the 80s. And let's say the latest addition was the Kingdom of Saudi Arabia, where fuel is almost free. They adopted fuel economy standards this 2015, and they're going to start regulating in 2016. So there is a wide variety of countries and markets that have adopted this standard. They understand that it's the best tool to reduce fuel consumption from their local markets. Now, one of the important elements of this slide, before we move forward, is that the reduction rates, the annual reduction rates should be between 3% and 6%. That's kind of what we call best practice. Below that is too little, and above that is too challenging for manufacturers. So between 3 and 6% of improvements per year is something that is achievable, and is it gives the right amount of benefits along a right time, let's say several years of standard implementation. So it's a good balance for governments to have this type of annual reduction targets. There is another element that is very important to, and we have learned this from the European experience, is that mandatory CO2 standards, fuel economy standards, are much better than voluntary fuel economy standards. It basically shows that during the voluntary implementation period before 2008, the fuel economy, the CO2 emissions for the European market improved by around 1% a year. And after the implementation of the mandatory agreements, the regulation, the reduction in CO2 emissions for the fleet jumped to 4% per year. So it is very important to keep that in mind when designing fuel economy standards. They have to be mandatory. The next topic is penalties. This is an important element, and the main idea is that the value of the penalty, these monetary penalties, should be set higher than the cost of the technology required for compliance. Low penalties open the door to manufacturers to pay to comply, which is a very bad practice, and erodes the effectiveness of the standard regulation itself. So just something to keep in mind. Now, the next topic will be complementary measures. And two of the main complementary policies that work very well with fuel economy or CO2 emission standards are fiscal policies and fuel economy label programs, information measures. Now, this is very important because on the one hand, fuel efficiency standards are targeted towards manufacturers, and they basically promote the offer of new technologies, efficient technologies on new vehicles. So it covers the supplier side of the equation. Fiscal measures and vehicle fuel economy labels cover the demand side of the equation by letting people take the information on fuel economy from the vehicle they are planning on buying it, and using this information to decide on the type of taxes that they want to pay, and basically the cost of the operation of the vehicle. So fiscal measures and information measures are very important as complementary policies for vehicle efficiency standards. And the most impressive example is we found it in Europe, when the Netherlands, before that was probably 2007, a CO2-based tax was adopted on diesel and gasoline vehicles. And before that time, the Netherlands, the fleet average was above the European average fleet. And after the introduction of this CO2-based vehicle tax, the CO2 of the fleet dropped significantly, even at a faster rate than the average European fleet, which is a nice piece of evidence on the effectiveness of combining CO2 information into vehicle taxation programs for vehicles. Now, the other, so we talk about the fiscal measures. This second set of measures, vehicle fuel economy label programs, bring awareness to consumers on fuel economy and CO2 emissions of these vehicles that are offered into the market. And some of these markets, like in New Zealand, they have fuel economy label programs for new vehicles in new vehicle showrooms, and they also have fuel economy label for used vehicles and vehicles that you buy on the internet. So there is a wide variety of label structures, but I think one of the most important elements is that this is a very easy program to implement. Actually, this slide is not complete. South Africa, as an example, has also labels, and Saudi Arabia and the Emirates, GCC countries also have labels, have adopted labels. So it's an easy program to implement, and the most important, what I think is the most important characteristic is that is the first step to implement fuel economy standards. So the label provides the data for regulators to develop the standards. They don't have to be, fuel economy label doesn't have to be before the standard is implemented, but having a fuel economy label already in place helps a lot during the development of the fuel economy standard. Now let's change a little bit into the technical details of the, we talked about before about the cost of vehicle emission standards. Now let's talk a little bit about the cost of CO2 emission standards or fuel economy standards. And this slide basically shows the benefit side of things. So, and shows some of the technologies that manufacturers are adopting in these new vehicles that are required to meet as a fleet, required to meet the CO2 standards. And manufacturers have a wide variety of technical options to reduce the fuel consumption, to reduce CO2 emissions. And these technologies, let's say, by applying these technologies, the vehicles that are produced consume much less fuel and emit much less CO2, which is shown in the x-axis on slide number 40. So let's say for a 2010 Ford Focus, the adoption of new technologies will result in a 31% reduction in CO2 emissions, and the cost associated with those technologies will be around €1,000. So that's kind of a typical average vehicle in Europe. So to reach the 95 grams per kilometer will cost about €1,000 per vehicle. Now, this will have a nice savings for the driver, depending obviously on the fuel price. Right now it's very low, but when we did the study, it was between 350 to 450 euros per year. And it has also additional benefits. The countries will import less oil, and there is also the need for investment in technology. So some of the countries where fuel economy standards have been adopted, they have to create jobs and basically develop the technology and the support of, let's say, for maintenance of this type of new technologies. So it creates, it's a source of economic, let's say, flow of money. So I think that's on the cost and the benefit side of things. And I wanted to show one example of preliminary calculation of CO2 reduction potential for South Africa, an exercise that we did with the transfer team in South Africa, with Christian Metke, your colleague. And basically, the annual reductions of implementing this type of programs are very large. Let's say if the CO2 emission standard is implemented by 2017 in South Africa as an example, just as an example, that will result in about 9% annual reduction within the next 10 years, so by 2027, and absolute of about 57% reduction by 2050, compared to a business as usual in case, let's say, South Africa doesn't adopt any fuel economy standards. So I think that the potential of this type of programs is massive, independent of the local market. There are not really technical barriers for implementation. It's basically political buy-in. This is very different compared to vehicle emission standards that require ultra-low sulfur diesels to be able to this is a condition for implementation. In the case of fuel economy or CO2 standards, there is no technical barrier for implementation, only political willingness. So the summary is that fuel economy and CO2 standards are powerful and extremely cost-effective tool to increase the efficiency of the fleet and reduce the carbon footprint. Mandatory standards are better than voluntary, and setting longer targets with 3 to 6% annual improvements is the best practice. The technologies are already available in all developed markets, and there are no significant barriers for technology transfer. And fuel economy standards and label programs, fuel economy standards are complemented very well with label programs and fiscal measures that are based on CO2 data for each vehicle. I think that completes the presentation, and I'll be very happy to answer your questions on these two topics.
Yeah, thank you very much, Francisco, for this impressive and comprehensive, but to my opinion, very understandable presentation. So I have learned a lot. Yes, and I would like to lead into the round of discussions. So everyone is free to ask questions via the chat function or via microphone. I would take back the control here in Ashbourne. So give me just a minute while you may still think about any question that you would like to address. Well, we need to go much further.
I don't see it.
Yes, a little bit further yet, because yeah, okay. So as mentioned before, you're welcome to raise your question during the chat function, or also use your microphone. Yes, for me the most interesting actually to maybe start a little bit was that that it's not automatically happens that the fuel economy standards or the emission standards that we have here in the US or in Europe, or that are in other countries with emission standards, that those automatically come to developing and emerging countries. So it is necessary to improve the fuel quality at the same time, which gives two important tasks to the national level to actually enforce policies for better fuel economy and for lower air pollution from vehicle transport. And yeah, so that link between fuel quality and fuel economy standards was very interesting to me. So we saw that it's actually not very expensive to implement that over the long term. So in that context, ICCT's work is very important to getting the facts right, and of course delivering the good arguments to policymakers as well as to car producers and anyone fighting for better standards. So that's actually quite good news, that policies are becoming more and more mainstream, and so hopefully we will hear in the future still some further good news from that side. So are there any questions from the audience? So at the moment there are...
I see Cristina Victoriano from Chile.
Yeah.
Trying to ask a question. Mm-hmm. Maybe the audio she's muted or...
Yeah, it seems that she uses the web browser, so now it might work. Yeah.
Hello everybody. I'm Cristina Victoriano from Chile. I hope you can hear me well.
Yes, we can hear you well.
We are here with a team. We are 5 people hearing you. First of all, I want to thank you for this presentation. It was very clarifying, and as you may know, we have in Chile a label program for the new vehicles, and it worked from 2013, and we are now planning. Well, we have also emission standards for vehicles running. At the moment, we're at the standard Euro 5, and we are planning to go further and move on to the fuel economy standards, and we are working on that. We're collecting information, so this presentation is very important for us. And I want to ask as a first question, because when we try to share with other actors that we're planning this regulation, they always raise the question that we're maybe enforcing a regulation who will bring more diesel vehicles, or the vehicles are more pollutant, and this will be a problem for our country, which is it has big issues with the pollution. And I would like to ask for which are the most important arguments to discuss better understand the difference between the two regulations.
Yes. So let me see if I got the question straight. I think that the adoption of vehicle fuel economy standards, we're talking about vehicle fuel economy standards. Well, first of all, I just wanted to mention that Chile is one of the most progressive countries in Latin America, I think, regarding the adoption of vehicle emission and vehicle fuel economy standards. And Chile is the leader on this type of programs. It's very good that you already have the fuel economy, the label program, because that's the source of your data for developing the baseline and setting up your targets for the future. I think that with respect to the issue of diesels, so those just two important things to mention. Vehicle fuel economy standards target, you can separate, you have to separate the fleet. So you have light-duty passenger vehicle fleet, and you have the heavy-duty commercial vehicle fleet. So it's very important to know if those diesel vehicles are, I assume, mostly on the heavy-duty side of things, and the light-duty itself might not be so, there might not be a large share of diesel vehicles. But if you want to keep the current share of diesel vehicles of these, of your light-duty diesel fleet, of your light-duty passenger car fleet, if you want to keep that diesel fleet low, the most important step is to change the regulation that covers vehicle emission standards, the one that regulates NOx, PM. So Chile right now, I believe, is at Euro 5. I'm not very sure. Maybe you already adopted Euro 6. But by having the Euro 6 regulation, that is a huge step. And that's very important if you want to mitigate or prevent a potential dieselization of the fleet in Chile from having negative impacts on air quality. At the end of the day, it doesn't matter if it's a gasoline or diesel vehicle as long as the vehicle is clean enough. Now, that being said, we know that some diesel vehicles, especially after this scandal, diesel vehicles emit 5 to 7 times more than the standard is allowed to allow them to emit. So that's one option. Just move from wherever you are right now, which is Euro 4 or 5, to Euro 6. That's step one. And the second step will be just use taxation measures to make the purchase of diesel vehicles less attractive to the customers. So if you have registration tax that is based on, I know that you have been, Chile has been trying to implement registration taxes based on fuel economy or CO2 information. If you also add the emission standard to that tax structure, you can impact the decision process for the people who's buying a vehicle and make sure that they don't see diesel vehicles as attractive as a gasoline one. So that will prevent, that will shield the Chilean market from an overflow of diesel vehicles. Now, diesel vehicle is not something that is needed to meet the standard, the fuel economy standard. Diesel technology is just one of the many technologies. We have hybrids, we have gasoline direct injection, turbochargers. There are many different options. Diesel is actually not one of the cheapest ones, but there is a possibility, and we have discussed that before internally at the ICCT and with some stakeholders. And if you're concerned about diesel, then move to Euro 6 and try to adopt as soon as possible the steps that the European Commission is adopting on implementation of real driving emission testing. That can be done a little bit down the road, but just keep track of that progress in Europe. Thank you. I see that there's additional questions. Let's see. So Mariano Gonzalez has two questions. The effect of Volkswagen scandal, because it means that all the CO2 standards were not real. Okay, very important to differentiate. CO2 standards and fuel economy standards are a different set of standards compared to vehicle emission of air pollutant standards, which is the ones that are, let's say, labeled as Euro 1, 2, 3, 4, 5, 6. So the Volkswagen scandal, especially in Europe and in the US, cover the emissions of NOx. It is not related with CO2, although the EPA found some interesting things regarding CO2, but that was not the main issue. NO2, yes, I think there is a push by London and the UK to implement NO2 standards. So that is something that is being discussed, and maybe it's going to happen, having independent emission standards for NO2 as part of maybe a national standard, because it's not part of the European as a group, as a European unit discussion. It's a local UK discussion right now, but it's an important discussion to have. And I would like to see actually an NO2 standard. Is more dangerous for health than NO itself. Any policy analysis in the impact of remove all vehicles for circulation and improve air quality and reduce CO2? So this covers the issue of scrappage programs, of vehicle replacement programs. This is not within the scope of new vehicle fuel economy or new vehicle emission standards policies. This goes a little bit beyond into the in-use fleet, the vehicle that are already being used. We have seen that the analysis shows that vehicle replacement programs are very effective if you target specifically problematic fleets. Let's say a fleet of old buses, and after doing the air quality analysis, you have pinpointed that old buses are the highest source of PM and NOx for your city. So then an scrappage or vehicle replacement program that targets that specific fleet of vehicles would be extremely helpful for air quality issues. They are not very helpful on CO2. There is not a good, we haven't seen good data showing significant reductions on fuel quality, on fuel economy or CO2 emissions. They are very good for NOx and PM, but not too much. There is not enough evidence, let's say, on the benefits for CO2.
Francisco, for the policy analysis in vehicle replacement programs, or I understood this question also a bit in this direction. Would you recommend your own study on that, as you have evaluated 8 vehicle replacement programs? Does that fit in there? Yeah.
Yes.
Okay, so I recommend that we will share this survey also with Luis, and of course it's also available on the ICCT homepage. Then, yeah, and there is one more question from our colleague Michael Schuster in South Africa, and that addresses the reluctance of the fuel refinery sector to implement sulfur specifications. Yeah, what is your experience about that, and what could be recommendations to tackle them?
Our experience is that we suffer a lot with this. This is our largest barrier for implementation of vehicle emission standards. We have seen this in Mexico right now. Is very dramatic. I have been directly working with the environmental authorities in Mexico, and we have everything done. The regulatory proposal for new emission standards for heavy-duty vehicles, which required a change from Euro 4 standards to Euro 6 standards. So buses and heavy-duty vehicles, trucks will need now SCR systems and DPFs, especially the DPF, the diesel particulate filter. We worked closely with the association, the manufacturer association, and everything was set up to implemented or to accepted this year, this 2015, sorry, that already finished, for implementation in 2018. And there was a condition during the negotiation that if the government doesn't sign off on ultra-low sulfur diesel, there will be no implementation of the regulation. So right now we have everything done, all the analysis, the regulatory proposal is ready, but our stop point is an assurance by the government that ultra-low sulfur diesel will be there covering the whole country. So it is a real issue. That is the single most difficult policy negotiation to have, is how to deal with fuel availability. Now, this is a very interesting question, because there are some countries, we have found countries that have ultra-low sulfur diesel all over the place, and they have Euro 2, Euro 3 emission standards. So it's basically, you can find in both sides of the situation. Countries that want to move to cleaner vehicles, but they don't have the fuel. Countries that already have the fuel and they have no idea they could have cleaner vehicles, because basically nobody told them that, hey, you can adopt Euro 6 right now, you have the fuel. So we find both. It's very interesting, yeah.
Yes, okay. With a little look to the watch, we are a bit over time, so I would use the chance to say again a big thank you to Francisco to providing us such profound introduction to those 2 topics, and I would like to recommend a few further sources which are interesting to investigate in terms of emission standards and vehicle standards, and that's one report where ICCT has been also a main contributor, the Fuel Economy State of the World in 2016, a document of the Global Fuel Economy Initiative, where also other stakeholders like UC Davis, the International Energy Agency, UNEP, and others are members of. Another one is, I highly recommend, as said, the webpage of ICCT. There you will find a lot of sources, a lot of information ordered by topics and by regions. So here also Luis Conde will find the survey on vehicle scrapping replacement programs, and also you might want to have a look at the webpage of the Transport and Environment NGO, actually an association of European NGOs which focus also a bit on policy analysis and reports. in that perspective, and some of the work on GIZ. So our colleagues in China have done significant work on not fuel economy standards, but on other technologies, particularly on electric mobility. So you might find a lot of information on their sustainable transport in China blog, and also on the SUTP webpage, you will find a few materials on electric mobility and unfortunately a bit outdated materials on cleaner fuels and vehicle technologies. So here I rather recommend to stick to the materials of ICCT and others. Yeah, one more general advice. You are probably all aware of the CAPSUT homepage, so here you will always find up-to-date information on any webinars, trainings, and e-learning activities in the field of urban transport. And here are a bit of further links to our knowledge sources, our photo database, our Facebook and Twitter channels, and our general homepages. So thanks a lot again to Francisco and for everyone for the active participation, and hopefully see you next time again.
I'll be happy to. Thank you for inviting me.